Okay, in this video, I'm going to cover how to do refutations and propositional logic. So refutations basically work the same way as proofs, where we're assuming that the argument is invalid, meaning that we are assuming that the conclusion is false and the premises are true. And if the argument is valid, we will be able to close every assumption that's made with a contradiction. Okay, so with the proof method, any assumptions that you make need to be closed by contradiction. Now, if the argument is invalid, that means that we will not be able to close off every assumption by contradiction. Okay, so every invalid argument is going to have at least one open assumption. Now, you can have more than one open assumption, but in order to prove that the argument is invalid, to refute the argument, you need to have at least one open assumption. Okay. Now, and the rules work exactly the same as they do with proofs. So, we're using modus ponens and modus tollens and disjunctive syllogism, and the various simplification rules. We're using the negated conjunct rule for a rule of inference. We're using, the negated disjunct rule as a rule of simplification, all those kinds of things. Okay. Now, and then the other thing that we do is we need to check off anything that we would need to make the premises true and the conclusion false. Now, and what we do, or how we do that rather, is with what's called a refutation box. Okay, so the refutation box would be the individual sentence letters or the individual values of sentence letters, which show that the premises are true and the conclusion is false. Now, Logicola does this automatically, but obviously when we're doing refutations by hand, the refutation box needs to be written out. Okay. Now, and how this actually works in the context of doing the refutation is largely anything which can be simplified needs to be simplified. So you can't refute an argument. You can't close it off by refutation and write out your refutation box until you have all of the values that you need to make the premises true and the conclusion false. Okay, and obviously I'll be going over how to do this in the course of the video. So let's go ahead and get into Logicola. Okay. All right, so I've got it set on propositional proofs, easy, and we're doing invalid. All right. Okay. So this works the same way. So we've got this argument. It's not the case that M only if not G, only if Y. It's not the case that if S, then not B. If not M, then not S. Therefore, it's not the case that if B, then not Y. Okay. So again, we're going to start by assuming the opposite of the conclusion. So since our conclusion is already negated, we're just going to delete that tilde. Okay. Now, in here on premise 2, notice that we have a tilde outside of a horseshoe. Okay, so once again, that means that the antecedent is true. So S is true. And not B is going to be false. Well, if not B is false, then B is true. Okay. Now, here with 3 and 5, we've got if not M is true, then not S is true. And we've got that S is true down here, okay? So by modus tollens, we can get not M. So if not M, then not S. Well, S, which is equivalent to not S, okay? So we can get not M, which is equivalent to M. Okay? Now, here on line 4, we have if B, then not Y, and we have B on line 6. So by modus ponens, we can get not Y on line 8, okay, from 4 and 6. Okay, and then Y is being used up here as the consequent of this conditional, okay? So it's false that if M then not G, only if Y, and we've got not Y. Okay, so by modus tollens, again, we can just delete this tilde in front of the antecedent. So that gives us if M then not G. Okay, all right, and then we have M and if M then not G, so we can derive not G on line 10. Okay, now here I've got training wheels on, so what logical is telling me is that I can't derive anything else. Okay, now, and how do I know that I can't derive anything else? Well, I've applied a rule of inference to line 1. I've applied a rule to line 2, as indicated by the stars here, line 3, and line 4. Okay, so notice all of these individual sentence letters or negated sentence letters that I have. All right, so on line 5, I've got that S is true. On line 6, I've got that B is true. On line 7, I've got that M is true. On line 8, I've got not Y is true. And then on line 10, I've got that not G is true. Okay, so what I've done is I've actually accounted for all of the sentence letters that are being used in the premises and all the sentence letters that are being used in the conclusion. So that's why I've simplified everything as far as I can. Now, but notice, I've simplified everything as far as I can. I've applied all the rules of inference that I can. I've applied all the rules of simplification that I can. I've broken up every complex formula here. So there's no need to make any further assumptions. Why? Since these lines are already broken up, if I were to make an assumption, I would just have redundancy in the refutation. I would get something that I already have on an individual line. Okay, so then the only thing left to do is to refute. Okay, now again, so Logicola sets up the refutation box automatically, but let's just go ahead and check and see how this works. Okay, so what this is saying is that given these values in the refutation, given the values of all these sentence letters, okay, S, B, M, not Y, and not G, so given that all of these are true, we have true premises and a false conclusion. All right. Okay, so let's go ahead and check them off one by one. All right, so the main operator of this premise 1, is this horseshoe right here. Okay, now, so I've got that not Y is true, which means that my consequent is false. Okay, now, and the main operator of the antecedent is actually this tilde. So in order for this main operator, this horseshoe, to be true, that means that the antecedent has to be false. Okay, so the antecedent, which is represented by this tilde right here, has to be false in order for this horseshoe to be true. Since Y is false, the only way for this horseshoe to be true would be for the antecedent to be false. Okay, so here I have that M is true on line 7, and I've got that not G is true on line 10, okay? But that makes this horseshoe right here true. So this is a true horseshoe, since M is true and not G is true. So I've got a true horseshoe, and this tilde is negating this horseshoe. So I have if false, then false, which makes this first premise true. Okay, so that checks out. All right, now, so this is saying that premise 2 is true, which means that this tilde, which is negating this horseshoe, is true. Okay, now, so I've got that S is true, and I've got that not B is false, right? So if B is true, that means not B is false, which makes this horseshoe false, which makes this tilde true. Okay, so premise 2 checks out as well. All right, now premise 3, I've got that M is true, okay? Now, but since M is true, that makes tilde M false, which makes this horseshoe true, okay? Now, and I've also got that not S is false. So I've got not M is false. Why? Because M is true. I've got not S is false. Why? Because S is true. So that makes premise 3 true, okay? And here I've got a false conclusion, okay? So this tilde is going to be false. Now, in order for this tilde to be false, this horseshoe has to be true, okay? So this conditional says if B is true, then so is not Y. Well, I've got B true right here, and I've got not Y true on line 8. So that makes this horseshoe true, which makes the tilde false. Okay, now, and that's represented by this assumption, right? So by making this assumption, by assuming the opposite of the conclusion, I cannot derive a contradiction, which means it's possible for the premises to be true and the conclusion to be false. That is how refutations work. Okay, but since given the value of all these individual sentence letters, S being true, B being true, M being true, not Y being true, and not G being true, okay, given the value of all those letters, it's possible to have true premises, false conclusion, hence this argument is invalid, okay? And that's what this refutation box over here represents. All right, let's go ahead and do another one. Oh boy. It's false that it's not the case that if not G, or not J, then G, and not T. That's a mouthful. Okay, so this tilde is negating this dot out here, all right? Okay, either not E or S, G, J, E, therefore it's not the case that if S, then not T. Okay, now notice what we have here. We've already got 3 sentence letters stated as premises on their own line. Okay, so that means that every one of these letters is going to go in our refutation box. Okay, all right. So for our assumption, whoops, I don't need a dot, I need a parenthesis. So for our assumption, again, we'll just be deleting that tilde in front of parentheses. So we will assume if S is true, then so is not T. Okay, now as far as simplifying lines, we've got on line 2, if not E is true, or I'm sorry, either not E is true or S is true. And we've got E true. Okay, so either triangle or box. Well, we've got not triangle down here. So if E is true, that means not E is false. So we can derive S on line 7. All right. Now here I have if S is true, then so is not T. And I've got that S is true, so I can derive not T. Now here I have, whoops, here I have a negated conjunct. All right. So once again, the negated conjunct rule is if you've got a negated conjunct and you know that 1/2 is true, you know the other half is false. So this is saying it's not the case that both not if not J then G and not T, and I've got not T on line 8. So I can go ahead and delete this tilde in front of this conditional formula right here. So I can derive if not J then G. Okay. Now, let's see here. I think that's all I can do. So let's see what happens when I do this. I have everything I need. Yep, there we go. Okay, now I'll just start here. So this is a complex formula, but how come I don't need to break this up? Okay, well, the reason why I don't need to break this formula up on line 9 is because I've already got that this is going to be true based on the values of other things that I have. Okay, so this is saying that if not J is true, then so is G. Well, I've got that G is true on line 3, and I've got that J is true on line 4. Okay, so that means that I have a true consequent and a false antecedent. So that's enough to make this formula true already. Okay, now, so I can't go back here, but if I were to assume either G is true or not J is true or something like that to try to break up this line, okay, well, I wouldn't assume G. Why? Because I've already got it. Now, if I assumed not G, I would immediately get a contradiction. Why? Because I've got that G is true on line 3. right? So if whether I assume G or not G, that would just be redundant. Now, the same is the case with the antecedent. So with the antecedent, I can either assume that J is true or J is false. Well, if I assume J is true, I've already got that on line 4. If I assume that J is false, if I assume not J, I'll immediately get a contradiction with 4 and that assumption line, which would be line 10. And then I would just discharge that contradiction as J, which again is something that I already have in the proof. So that's why I don't need to break up this formula. Okay, now, but if I didn't have these values already represented somewhere in the proof, I would need to make a further assumption to break up this line. Okay, now, and this is an important thing to remember about refutations. Any assumptions that can be closed off doing refutations need to be closed off doing refutations. So even though for every refutation you're going to have at least one open assumption, any assumptions that you can close by contradiction do need to be closed off by contradiction. Okay, so if I didn't have premise 3 or premise 4 here, so let's just say that I didn't have either one of these premises in this proof, I would need to make a further assumption with line 9 to break up that formula, right? I would either assume not J or J, I would assume G or not G, and then I would see where that would lead me in the proof, okay? Now, so like we did before, let's go ahead and check our refutation box and see if we have everything we need. Okay, now this is a doozy right here. So the main operator of this formula is this tilde out here, and this tilde again is negating this dot. Okay, so keep in mind that this tilde is going to be true, which means this dot is going to be false. But there's 3 different ways that a dot can be false. Okay, so let's see what we have. So we've got not T in our refutation box, and we've got that on line 8. So this is true, not T is true, which means that this formula is going to be false. Okay, so I've got false and true. Okay, but in order for this to be false, okay, in order for this to be false, this horseshoe has to be true. All right, so in order for this tilde right here, this one outside of the conditional to be false, this horseshoe needs to be true. Okay, well, I've got that G is true, which means the consequent is true. And I've got that J is true, which means not J, the antecedent, is false. So I've got a false antecedent and a true consequent. That's enough to make this horseshoe true. Okay, which means this tilde is false. So I've got false and true, which means this dot is false, which means this tilde is true. Okay, so based on the value of G, J, and not T, premise 1 turns out to be true. Okay, here I've got either not E or S. Well, I've got S true on line 7. So since 1/2 of this disjunct is true, that's enough to make this true. Okay, and then I've got G, J, E all stated on their own lines, and I don't have anything here that contradicts any one of these lines, which means all 3 of these things are true. Okay, and then I've got a false conclusion. Okay, so once again, this tilde, which is negating this horseshoe, is false, which means that the horseshoe is true. Okay, so I've got if S, then not T, and I've got S on line 7, and I've got not T on line 8. So that makes this horseshoe true, which is represented by this assumption, which makes that tilde in the conclusion false. So based on the value of these letters, J, G, E, or G, J, E, S, and not T, I've got true premises, false conclusion, and hence this is an invalid argument. Okay. Now, let's go ahead and do some harder ones here. And I'm going to turn off training wheels. Okay. All right. So here we have either it's not the case that not X and S, or it is the case that not E and K. Okay. Premise 2 is it's not the case that if not K, then Q. And our conclusion is therefore either Q or not X, right? So either it's not the case that not X and S, or it is the case that not E and K. Premise 2, it's not the case that if not K, then Q. Therefore, it's not the case that either Q or not X, okay? So since our conclusion is negated, we're just going to assume the opposite. So we're just going to delete that tilde outside of parentheses. So we're going to assume either Q or not X, okay? Now, as far as lines that can be broken up, line 1 is a wedge, and I can't break this up until I know that either one of these things is false, okay? And I don't have that. Now, but premise 2, I've got a tilde outside of a horseshoe, okay? So this can be simplified to not K from line 2. So if this horseshoe is false, that means that the antecedent is true and the consequent is false. So I can simplify to not K. I can also simplify to not Q. Okay. Now, and here with my assumption line, I've got either Q or not X, and I've got not Q on line 5. So I can derive not X by disjunctive syllogism of 3 and 5. Okay, so I've broken up this line, I've broken up line 2, I've broken up line 3. Now I still have this right here. I still need to deal with this, okay? Now, I'm going to go ahead and assume, oops, not E and K to break line 1. Now, why did I assume this? I assumed this because I've already got not K right here, okay? Now, if I assume not E and K, that line can be simplified to just K. Now, but notice, I've already got a contradiction here. So I've got a contradiction between line 4 and line 8, which means that this secondary assumption that I made on line 7 is going to be false. So I assumed not E and K, and that led to a contradiction with line 4 and line 8. Okay, so that means I can discharge this assumption. I can close this assumption off. Now keep in mind, this doesn't mean we've proven the argument valid. Why? We've still got an open assumption here. So even though we closed off this secondary assumption, we still have an open assumption, okay? Now, so here I have either it's not the case that not X and S, or it is the case that not E and K. And down here on line 9, I've got, well, this half of the disjunct is false. So it's false that not E and K, which means it's true that it's false that not X and S. So by disjunctive syllogism, I can bring this whole thing down. Okay? So either triangle or box, and I've got that box is false on line 9, so I can derive that triangle is true on line 10. So either it's not the case that not X and S, or it is the case that not E and K. All right, well, it's not the case that not E and K. Therefore, it's true that it's not the case that not X and S, okay? Now, so here I've got not X conjoined with S, and I know that this conjunction is going to be false, all right? Now, but here on line 6, I've already got not X is true, so I've got, it's not the case that these are both true, and on line 6, I've got that 1/2 of this is true. So on line 11, I can derive that S is false, okay? So these aren't both true, and I've already got that 1/2 is true, so I know that the other half is false, okay? Now, but notice what I have here. Let's see if we have enough to refute. So I've got not Q, or sorry, I've got not K, I've got not Q, I've got not X, and I've got not S. all right? Okay, now, since this is a disjunct, so this is a disjunct, I only need that 1/2 of this is true, right? So a disjunct is true just in case 1/2 of it is true. Okay, but I already know that this half is true. Why? Because not x is true and not s is true. Okay, so that means it's false that not x and s. So that's enough to make this true. All right. Now with premise 2, I've got that not k is true, and I've got that q is false. Okay, so that means that this horseshoe is false. That's why I've got true antecedent and a false consequent, which makes this horseshoe false, which makes this tilde true. Okay, so this premise is true. Now my conclusion, I've assumed the opposite of the conclusion here, so q or not x, all right? Well, I've got that not x is true, and I've got that q is false. Well, since not x is true, that's enough to make this horseshoe, or this wedge true, this disjunct true, which makes this tilde false. So q is false, so I've got false or true, which makes the wedge true, which makes the tilde false. So I have enough to refute here. So this argument is invalid. This argument is invalid based on the values of not k, not q, not x, and not s, right? So the values of not x and not s are enough to make first premise true. Why? That makes this wedge true, and a wedge is true just in case 1/2 of it is true. All right, the values of not k and not q make this horseshoe false, which makes this tilde true. And then the value of not x in particular makes our assumption true. And since our assumption is true, our conclusion is false. So this is invalid. Okay, let's go ahead and do one more here. All right, I've got either q or not p. If q, then not s. It's not the case that not p if and only if s. Therefore, it's not the case that if s, then not p. So either q or not p. If q, then not s. It's not the case that not p or s. Therefore, it's not the case that if s, then not p. All right. So for our assumption, we're just going to delete that tilde. All right. Okay, now as far as lines that can be broken up, line 1 cannot be broken up, can't be simplified unless I know that either q is false or not p is false. And right now I don't have either one of those things. Line 2, if q, then not s. All right, I can either prove q true or s true, which means not s is false. But again, I don't have either one of those things. All right, the only line I can simplify is line 3. So line 3, I have a tilde outside of a triple bar. All right, so line 3 can be simplified to either p, or I'm sorry, either not p or s. And it can also be simplified to it's not the case that not p and s. Okay, so a false triple bar can be simplified to just either not p or s, and it can also be simplified to it's not the case that not p and s are both true. Why? Because if not p and not s were both true, that would make the triple bar true, and I know that the triple bar is false based on premise 3. All right. Okay. Now, so that line 3, can be simplified, but nothing else can. So I need to make another assumption. Now, since not p is now being used in 1, 2, 3, 4 different lines, I'm just going to assume not p to break line 1. Okay. Now, that doesn't help me here. That doesn't help me here. And that doesn't really help me here. Okay, now, but it does help me here with line 6. Okay, so on line 6, I've got, it's not the case that not p and s are both true, right? So since I know that not p is true, that means I can derive not s. Okay, so I've got two live assumptions here. But now notice, can I do anything else? No, I can't. Why? All right. So premise one says either Q is true or not P is true. And I've already got that not P is true. So that means that line one is true. Line two says if Q is true, then so is not S. All right. Well, I've got that not S is true. So I've got a true consequent, which is enough to make this horseshoe true. Okay. So line three, I've already broken up, right? So it's not the case that not P if and only if S. Well, I've got that not P is true and not S is true. So that's enough to make this triple bar false, which makes this tilde true. Okay. And again, I've got that S is false and not P is true, which makes this horseshoe true, which makes this tilde false. So I've already got enough to refute here. I don't even need to worry about Q. Now, I don't need to worry about Q because Q is being disjoined with not P, and I've already got that not P is true, which means that this premise is true. Here, Q is joined conditionally with not S, but Q is the antecedent and not S is the consequent. But keep in mind that a horseshoe is true anytime either the antecedent is false or the consequent is true. And I've got that the consequent is true, so that's enough to make premise two true, okay? Now, the only line that we broke up was line three, so either not P or S, and it's not the case that both not P and S. Well, the values of not P and not S make statements 5 and 6 true, which makes statement 3 true, okay? And since not P and not S are being used here in the conclusion, so S is false, not P is true, which makes this horseshoe true, which makes this tilde false. So that was a very simple refutation. Now, notice here, so with the last proof we did, or the last refutation we did, we had a secondary assumption which could be closed. Here I've got two open assumptions, and neither one of those assumptions can be closed by contradiction. There's nothing left for me to do here. So I've already got everything I need to refute this argument, show that this argument is invalid. All right. But so since that one was relatively simple, let's go ahead and do another one. I lied. We're going to do one more. Oh, here we go. All right. So either P and N or not S. Okay. Either if not N, then B, or S, therefore N. All right. So our conclusion is a single sentence letter here. So let's just assume not N as our conclusion, or right, we're assuming the opposite of the conclusion. So the conclusion is N, we're assuming not N. So this one also looks like it's going to be relatively easy here. All right, now line one can't be simplified. It's a disjunct. So in order to break this down any further, I either need to prove that not S is false or P and N is false. And again, with line two, I've got another disjunct. So the only way to break this up would be to show that one half of this is false, okay? Now, so just for kicks and giggles, let's go ahead and I don't want this to be too easy. All right, let's assume P and N. We'll go the long way. Let's assume P and N to break up line one. All right, so I've assumed that this half is true. Now, but this can be simplified. So P is true and N is true. That can just be simplified to N. Now, but notice here I've got a contradiction between 3 and 4, right? Okay, now, so that means that it's not the case that P and N. From 4 and 3 contradicts 5, okay? Now, but now notice what I have here. I've got either P and N or not S, and I've got, it's not the case that P and N, okay? So either triangle or box, and I've got not triangle, right? So that means I can derive box. So either triangle or box, and I've got not triangle, so I can derive box, okay? Now, notice what I have here. I have either if not n, then b, or s. Down here on line 7, I've got not s. Okay, so either triangle or box, and here I've got not box, so I can derive triangle. So if not n, then b, right? Okay, now, and I've got not n on line 3, and I've got if not n, then b on line 8, so I can derive b. Okay. Now, but notice what I have here. This line is simplified, this line is simplified, and then this line is simplified, line 8. So all of my complex formulas are simplified. They're all broken up as far as they can go, okay? Now, let's see if we have enough to refute. So premise 1 is either p and n is true or not s is true. Well, I've got not s is true down here, which is enough to make this disjunct true. So premise 1 is true, all right? If not n, then b or s. Well, I've got that s is false, so that means that this half is false. Now, but here I've got not n is true, and I've got b is true, which makes this horseshoe true, which is enough to make this disjunct true, right? So premise 1 is true, premise 2 is true. My conclusion is just n, and my assumption not n. I don't have anything that contradicts that, all right? So my assumption can be true, that the conclusion is false. So I've got true, true, false. So I've got enough to refute. So the values of not n, not s, and b. This is enough to make this argument invalid. Okay, now, just for kicks and giggles, I want to go back and make a different assumption here. All right. So we'll start the proof the same. We'll assume not n, okay? And once again, I can't simplify anything else. So last time we assumed p and n, okay? This time, let's assume not s. Whoops, I gotta write an assumption here. Let's assume this and see what happens. Break line 1. Okay, now my assumption not s makes this line true. Okay, so the only thing I have left here is to break this formula up. All right, so if not n, then b or s, and I am assuming that s is false, which means once again, if either triangle or box, and I've got not box, so I can bring down not triangle, or I can bring down triangle, thinking of a conditional here. Okay, so I assumed not s, and that makes this half of the disjunct false, which means this half of the disjunct is true. And now again, I've got if not n, then b, and I've got not n on line 3, so I can derive b. Okay, and again, I've got the values of not n, not s, and b. So once again, I've got enough to refute. Okay, now, so by assuming p and not n, I was able to derive a contradiction. Now, but by assuming not s, I was not able to derive a secondary contradiction. So if you assumed not s, you would have 2 open assumptions. But if you assume p and n, you would have 1 closed assumption and then only 1 open assumption, okay? Now, do I want to do everything else? Nah. All right, we'll just leave it at that. Okay. All right. So again, if we need more practice doing refutations, by all means, we can slow things down as far as we need to, but this will serve as an adequate introduction for now. All right. And as always, if you have any questions, do not hesitate to email me. I'll see you all soon.